Hi guys, on this video, we'll teach us the steps and calculation of building a DIY 48 volts off-grid solar power system. Number 1. Load computation of daily energy consumption. Look the power rating on each appliance you always use every day. The energy consumption, WH, equals power, W, times time, hours. Example, LED bulb, 10 pieces times 10 watts times 3 hours used is equals to 300 watt hour. Electric fan, 2 pieces times 200 watts times 2 hours is equals to 800 watt hours. LED TV is 2 times 150 watts times 4 hours use is equal to 1200 watt hours. And sound system is 1 piece times 100 watts times 1 hour use is equal to 100 watts hour with the total of 2400 watts total energy consumption on a day. So we locate and calculate the continuous load and surge watts for the future calculation. To make this one, on the bulb, we have 10 times 10 watts is 100 watts. Electric fan is 2 pieces, 200 watts become 400 watts. TV is 2 pieces times 150 watts is equals to 300 watts. Then sound is 100 watts and the total of 900 watts continuous load. But if we find the surge watts is only additional on 2 electric fan, that is 200, so it becomes 800 watts. Then added to the remaining from bulb 100 watts, TV 300 watts, sound 100 watts will become 1300 watts surge watts. Now we know already the daily energy consumption, the surge watts and continuous watts. So we can calculate now the battery storage. This is step 2, battery storage calculation. First, we decide a 48 volts solar voltage system because we have also 12 volts, we have also 24 volts, but we decide a 48 volts solar power voltage system. Then on the battery selection, we have these two types, the automotive battery and the deep cycle battery. But we prefer a deep cycle type of battery. On the deep cycle battery, we have also two classification. We have this lead acid and we have also a lithium battery. But we prefer a lead acid battery because it is cheaper. But the DOD is only 50% depth of discharge. Now, we start to calculate the battery storage. The formula of battery storage is battery capacity, ampere hour, is equal to daily energy consumption or WH over system voltage, which is 48 volts, times the DOD 50%. So we have 2400 watts hour daily energy consumption divided by 48 volts battery bank as a system voltage times 50%. It will equal to 100 ampere hour battery capacity. Since it is 48 volts voltage system, we have to buy 4 pieces batteries, 12 volts, 100 ampere hours, which is connected on series. We bear in mind that a series connection of 4 batteries of 12 volts 100 amperes will become a 48 volts 100 ampere. We go now on step 3. solar panel selection and calculation. Remember that our daily energy consumption is 2,400 watt-hour, and the typical entire solar power system have efficiency of 70% due to the dust collection of the solar panel, shading from the clouds from the trees of our solar panels, and wiring losses. Depends upon the sizes of the wire and connection. On this calculation, we consider also the 5-hour sun peak hour to our solar panel, which exposed depends where you have country located and how you install your solar above the roof or any location. So we have now a solar panel watch calculation. Solar panel watch is equal to daily energy consumption or watch hour divided by sun peak hours times system efficiency. So we have 2,400 hours daily consumption, sun peak hour 5 hours times 70% system efficiency is equal to 685.71 watts or round off 700 watts. Since we have a 48 volt system, so we use a 2 pieces 350 watts 24 volts that connected on serial, on which voltage becomes 48 volts and remain 9.25 amperes on 700 watts. Here is one of the example of the specification of 350 watts solar panel depending on the model. The maximum power voltage VMP is 37.8 volts. Short circuit current IEC is 10.82 amps and maximum power current IMP is 9.25 amperes. These three values is very important in our future calculation. We are now in step 4, solar charger controller sizing. We have 130% as a safety factors that our solar panel watts maximum will rise during sunny days. The formula is the maximum system current of solar charger controller is equal to solar panel watts divided by system voltage multiplied by safety factors is equals to 700 watts over 48 volts is equals to 14.58 amperes multiplied by 1.3 or 130% is equals to 18.96 amps or 20 amps. Since we have system voltage of 48, so we chose a solar charge controller 20 amperes 48 volts. But we have two types of solar charge controllers. We have the PMW and we have MPPT. So we prefer MPPT. We go now on step 5, solar power inverter selection. If you have a 48 DC volts load, will not need this solar power inverter. But if you have a 110 volts or 220 volts of appliances, will need a DC to AC solar power inverter. Remember that most of DC to AC inverter have 95% efficiency. So we have now the formula of inverter selection. Inverter rating is equals to surge watts divided by inverter efficiency. If we remember that we have a total surge watts of 1,300 watts, it is divided by the inverter efficiency 95%. So convert 95% becomes 0.95 into decimal. So we have now 1,300 watts divided by 0.95 is equal to 1368.42 watts as a maximum surge watts. So we decided to choose a continuous watts 1000 watts with the surge watts of 2000 watts. DC input voltage is 48 volts and AC output voltage is 230 volts 60 Hz. Pure sine wave inverter. Now we go to step 6, cable size selection. Since we have a serial connection of 2 pieces 350 watts, we'll add the voltage to become a 75.6 volts or VMP with similar current 9.25 amps IMP and will be installed on 20 feet long cable with expected 1% voltage drop inside the tube raceway. And we put all of these numbers to a solar wire size calculator that we can find on internet. And according to this solar wire size calculator, we will use a 12 EWG copper wire. But if we like 0% voltage drop, we can use more than of this 12 EWG copper wire. So from this calculation, we have now a cable from solar panel to solar charger controller going to the battery bank is 12 EWG copper wire. Since we choose a 2000 watts surge power of our inverter, which is 48 volts DC input from our battery bank, so we can calculate like this: 2000 watts divided by 48 volts is equal to 41.67 amperes. From this calculation, we refer now the chart of American wire gauge. Is 41 to 67 amperes on the chart. So we can make 50 amperes based on wire ampacity chart. Will be used a copper number 8 EWG, meaning that the power inverter cable to battery bank is number 8 EWG copper wire. Since we choose a 2000 watts surge power with 230 volts AC output of the solar power inverter, so we can calculate also like this: 2000 watts divided by 230 volts is equals to 8.69 amperes, on which this on the American wire gauge charts is 15 amperes. So we will use a copper wire of number 14 EWG. So the power inverter to AC loads cable will be used a copper wire number 14 EWG. We go now on step 7, fuse and breaker design. Our 2 pieces solar panel was series connected that have similar short circuit current of 10.82 amperes IEC. So according to NATE, DC fuse and breaker size have 156% demand factor. So our circuit ampacity is equal to short circuit current IEC times 156% demand factor is equal to 16.8792 amperes or 15 amperes fuse. So between solar panel to solar charger have 15 amperes fuse or breaker. Now remember again that the inverter with 1000 watts continuous watts with 48 DC volts input. So, circuit ampacity is equal to inverter continuous watts divided by battery bank voltage times 156% is equal to 1000 watts continuous watts of inverter divided by 48 volts battery bank voltage times 156% equals to 32.5 amperes or 35 amperes fuse or breaker. Meaning that between solar power inverter and battery bank is 35 amperes fuse or breakers. Again, our inverter have 1000 watts continuous power on 230 volts AC output power. So according to NEC or NEC, National Electrical Code, that AC fuse and breaker size have 125% demand factors. So, our circuit ampacity is equal to inverter continuous watts divided by AC inverter output times the demand factor of 125% equals 1000 divided by 230 times 1.25 equals to 5.43 amperes or 6 amperes fuse or breakers. Meaning that between solar power inverter to appliance load have 6 amperes fuse or breakers. So, we are now done for all computation, size, and selection of our DIY 48 volts off-grid solar power system. I hope that you learned something on how to build a DIY 48 volts off-grid solar power system according to the different steps we have. Thank you for watching. Please don't forget to subscribe, like, share, and follow to my channel, Knowledge Link Information.